Hello and welcome to this talk about migrating large-scale Cloud Foundry environments. My name is Julian Fischer. I'm CEO of Any9s and we are focused on building and operating application development platforms with a strong focus on data service automation. So in this talk we are going to look into what to do with large Cloud Foundry environments, especially if you want to migrate them. This could be for various reasons, and we are looking into some of the scenarios that we see on a frequent basis. So we set a context for this talk, look into how to migrate Cloud Foundry itself, especially the applications. We'll spend a bit of time looking into how to migrate data, as this is the most complicated part, and then wrap it up. So first of all, the scale we are looking at is Cloud Foundry environments, mostly basic on classic Cloud Foundry. So thinking about virtual machine-based Cloud Foundry using BOSH as its infrastructure abstraction layer. These environments often have hundreds, if not thousands, or even more applications running in such a single Cloud Foundry. So these are gigantic. So what to do with those environments if you need to move them is the question of the talk. Of course, no applications these days they can run without storing data somewhere, especially if they're designed as cloud native applications being 12-factor compliant. These applications store their data in backing services, so-called data services, and they need to migrate it. They need to be migrated as well. So what are the scenarios when you want to do a migration for a large Cloud Foundry environment? Well, there are several triggers for such a migration we've seen in the past. Some of the more frequent ones are migrating within the same infrastructure. This could, for example, be if you want to move away from your existing open source Cloud Foundry stack to another one. For example, in our case, we have customers running Cloud Foundry themselves, but they're in over their head, they have trouble and want Any9s operators to do it on, or they just want to migrate to our Cloud Foundry, which is based on open source but comes with rigorous testing and also support and additional components for monitoring and all that. So this could, for example, trigger the motivation to move a large Cloud Foundry environment within a data center to another Cloud Foundry. One of the other scenarios is, for example, changing the infrastructure. This could be for legal reasons because you want to operate under a different jurisdiction, so you'd migrate towards an infrastructure vendor, for example, Ali Cloud in China, that's very close to the Chinese government, or because you want to mitigate infrastructure costs, you got discounts in the beginning, discounts are now not available anymore, and a different infrastructure provider gives you a better price. Or let's say you started in an on-premise scenario, let's say on OpenStack, but now want to move to Amazon, or the other way around. This is also when you want to migrate from one infrastructure to another. So if we now think about how such a migration may look like, there's basically a fundamental pattern on how to do that. And that fundamental pattern is basically you look at a source Cloud Foundry and a target Cloud Foundry, and you pull object data from that source Cloud Foundry using a migration tool, and you write that objects into the target Cloud Foundry. That's the basic idea. You pull information, metadata and data from the source environment and you put it into the target environment. This obviously means a few things. First of all, these environments need to run simultaneously, and also your migration logic needs to have access to both environments. Sometimes this can be done easily. Sometimes connecting those two networks can be a bit more tricky. But I mean, there's always a migration is always a project. So as much as you can automate, a lot of the steps, not all of them can be automated, and there's always a bit of a project with unique circumstances to each migration. So at Any9s, we've done a lot of them, and each migration is similar to the others, but also comes with its unique challenges. So the migration pattern where you pull object data from the source Cloud Foundry, reading those objects using the Cloud Foundry API, and then write the data to the target API, target Cloud Foundry API, is applicable to most of the objects, not to all of them. UAA users are, for example, an exception to this. The reason is that Cloud Foundry only contains the GUID of the user in the UAA. So there's a different sequence where you have to get the user GUID from the source Cloud Foundry API, then get the information from the source UAA, create the user in the target UAA, and then create the user object in the target CF. So that the association of the GUIDs is done correctly. As you can see, using this example, such a migration is something you need to spend some time in preparation. So it would be good to have staging environments or testing environments where you can test your migration logic and migration scripts rigorously. So in the remainder of the talk, we are looking into particular chapters of such a migration, and I'll talk a bit about those chapters and give you some general advice which you can take away when you migrate your Cloud Foundry environments. The migration of a Cloud Foundry environment does not always mean that you'll migrate from one version to the very same version in a different infrastructure or the same infrastructure. It could be a different Cloud Foundry version, and usually this is not a problem. However, if the version differences are too big, or there's a particular version difference where those metadata objects have changed in structure, that could imply some challenges. In particular, it may require objects to be reformatted. For example, there could be new attributes, or the attributes have a different syntax, so your script has to then somehow provide new values or transform them in some way. In general, it is you have those objects in your source Cloud Foundry, you have those objects in the target Cloud Foundry, and wherever you deal with object resources that need to exist in both environments, you need to be aware that they can change their identity. So for example, if you create an object, let's say an organization or a space or something like that in the target Cloud Foundry, it's very likely it has a different GUID. And that requires a mapping from the object's identities in the source system to the object identities in the target system, especially if those things relate to each other. For example, I don't know, service binding, being bound to a particular app. You want to bind that service binding, you want to create that service binding for the newly created app, not for the old one, in case GUIDs or identities have changed. So in this case, you would see that the migration scripts need to know the identity of the old version and the new version, and performs that mapping during its execution. For example, resource mapping for application objects is done by getting the space GUID from an app from the source Cloud Foundry, getting the org GUID from the space from the Cloud Foundry, source Cloud Foundry, get the organization name of the organization from the source Cloud Foundry, find the organization in the target Cloud Foundry by using the organization name from the source Cloud Foundry. This is possible because organizational names are unique in Cloud Foundry, With other resources, you need to add more logic to it to avoid pulling objects that have the same name but actually are different objects. And then you find the space in the target CF by using the space name given the organization name. Within an organization, a space name is also unique. And finally, you find the application in the target Cloud Foundry by using the application name and its space GUID from the target Cloud Foundry. So here you can see where, for example, a piece of information is preserved, like the application name, but another piece of information has changed the target, the space GUID of the target Cloud Foundry. So this is where resource mapping is important. It's similar for other resources that have some sort of association among each other. So the idea transfers. Now you remember we spoke about that those Cloud Foundries need to coexist. In most of the cases, they're doing such a migration. You have a certain phase where the source system is still in production. You've created the target environment already, and now you want to prepare the transfer of data to that target system, which means that one system is in production and the other isn't. If you want to migrate, which at some point you'll have to also migrate your domains if you don't want to, change, the application's domains, for example, or the system domain of the target Cloud Foundry, which also means that you'll have to configure the target Cloud Foundry with temporary domain names while the target Cloud Foundry is the shadow of the source Cloud Foundry. So reconfiguring Cloud Foundry domains isn't as simple as it may appear in the first place. It's not enough to change the domain, but you also have to delete all internal certificates from CredHub that use that domain and deploy Cloud Foundry to change the domains and then trigger the regeneration of the certificates with the correct domain. So there are things like that that are very essential to the success of your migration. And if at some point you can then swap out, the target's domain, the domains in the target Cloud Foundry for both the system domain and the application domain. However, Rome wasn't built in a day, and a large Cloud Foundry aren't migrated in one either. So if we're talking about thousands of apps with data, such a migration will take longer than just a few hours. It will potentially take a few days. So we need to have a strategy how to approach such a migration in a graceful way. We're finding a balance between consistency guarantees as well as minimizing the downtime. The approach to this would be to make the migration logic able to run in several iterations, which means that in the first run you transfer the bulk of data. You have a long runtime of the migration logic, but no downtime of the source system. You transfer most of the data during that iteration, and also sync most of the overall state of the source system. This ideally includes both applications as well as data services, assuming that you have a migration logic for data services as well, which we'll talk about in greater detail a bit later. So the migration logic will likely to be run multiple times. That's one of the takeaways, is if your environment isn't small, it's very likely that you want to have such a pre-run, and then in the second run, you do that little delta that's left, maybe even blocking access to the Cloud Foundry for a certain amount of time to ensure consistency. So that last run will be short in runtime. It will, operate, it will take place with a minimal downtime, but with a downtime. And the goal is to sync to completion before you switch over. So it comes to mind that if you want to run that logic several times, it's very important that all the actions you take in your migration logic are idempotent by design, which means that you don't want to create objects and duplicates in the target Cloud Foundry. So migrating data is, once we have the outline of the migration, we should have a bit of conversation about how to migrate data, because this is where things get messy. While Cloud Foundry allows you to, deploy applications, set domains, configure apps and all that, dealing with data is a different thing. There's much more heterogeneity in data than there is with applications, which means you have to think about how do you access the data you want to migrate in the first place. Because this isn't really part of Cloud Foundry anymore. You have service brokers who do one or the other kind of magic to provide you with data services, or you have user-provided services where all you do is store credentials in Cloud Foundry and you don't actually know where the data are and how to move it. So the migration pattern is pretty similar. You pull the data from the source system, and in this case we assume it's a cross-infrastructure migration where we also have to move the data. For example, customers using our Any9's data services, before they migrate to our Cloud Foundry, they can often preserve their data and just reconnect server applications to existing service instances. However, if you use some other data services and you want to move to a new infrastructure, well, then you also have to migrate the data service instances. So either you want to move from one data service solution to another, you need to migrate data most likely, or if you want to move from one infrastructure to another, then you also have to do that. The idea is basically the same. You create service instances using backup and restore. So you create backups in the source system, you create service instances in the target system, and then you perform a restore. Now, the data service challenge is generally harder to solve than the application challenges, because data services have state, and that makes it harder to deal with them. State also means that different databases, they have different query interfaces, they have different ways of storing state. They're in-memory databases, they're relational databases, they're document databases. So while there's certain commonalities among databases, there's also a vast space of differences. And these differences, they create heterogeneity, also from the operators on the application developer's perspective, which makes migrating data also hard. Each data service is different, and there are also a lot of them. So if you look at that list, we are talking about just relational databases. So there are many more different types of databases with many more database candidates you could potentially find in such a Cloud Foundry environment where applications depend on those services. Now, each of those different services will have a different backup and restore functionality. For sure, they'll have some things. There will be some tools to do that, at least if the automation is proper. So if you look into the backup and restore of different data services, you will see that there's some basic strategies. So most of the data services, they allow you to do two things for sure, which would be to dump the schema, whatever your schema is. For example, in RabbitMQ, it could be the queue structures, where it's in a relational database, it would be the tables, the indexes, and all that. And where applicable, you'd be able to dump the data and restore the data from such a dump. For example, using MySQL or Postgres or MariaDB, you just take the data, dump it into a file, and on the other end, you will restore it. So that is, well, let's say a common denominator. Most of the databases, they have something like that. Not all of that. Some databases or some data services doesn't have to be a database at all. Talking about, for example, Elasticsearch or OpenSearch, they have very particular strategies on how to create backups, which is harder to generalize as this dump and restore idea doesn't apply there. So you'd have to make exceptions for them and dig deeper into the data service and how to make a restore, backup restore story work. It's possible, but it may imply you diving deeper into the rabbit hole than you actually anticipated to. Just to give you an example on some advanced backup strategies, this would be, for example, streaming backups. Postgres, for example, with its write-ahead log streaming, allows you to do very nice things, including point-in-time recovery backups, which could be very handy, especially in asynchronous replication across infrastructures, where you could continuously stream data to a remote location before you do the switch over to the database you write to. However, this requires orchestration that's beyond the capabilities of most automation products these days. We are at Any9s working on such functionalities and hopefully provide you with a more pleasant experience in migrating large-scale environments in the future. For the data services that we automate, there's roughly a dozen of them. There's a backup and restore functionality where the data service makes sense of it. So that helps with migration a lot, because the underlying migration idea is and pattern is applicable again, where you take your source system, read the objects there, create the service instance in the target system, and restore your backup. Now, having a service instance is one thing, but you also have to create the service bindings and the applications so that the applications have access to the data service instances. In Cloud Foundry, that's a service binding. Whether this is a fully featured service broker or just user-defined services, the service binding is an object that needs to be migrated along. And you also need to ensure referential integrity. So the applications need to find a service instance bound to the application that provides access to the same data as before. So in our examples, it's possible to create a data service instance that's equal to the other data service, because our data service automation is infrastructure agnostic. So you can, for example, create a Postgres database on AWS, on OpenStack, vSphere, or AliCloud the same way, and backup and restore functionality will work across those boundaries as well. So basically creating a service instance, creating or restoring backups will help you apply that migration pattern a lot and make the migration much easier. So the structure of service bindings are specific to the service broker implementation. So if you're dealing with one automation product, let's say a Postgres here and a different Postgres there, that could be a challenge, because also your application has to be adapted, because it's very likely that the VCAP services environment variables providing access, for example, the way the host names are presented or the way this whole service binding is structured in that VCAP services variable may differ, for example, by naming, but also by structure. So again, you'd be looking into some sort of resource mapping where your migration logic needs to be adapted to the particular case, which in data migration will be often the case that you'll have to invest some brain power to do that resource mapping. Last but not least, if the information has changed, you'd also have to restage the app. Depending on how your migration works, you'd have to do this anyway, but and it's not a problem, you can script that, but it's something that needs to be taken into consideration eventually, potentially. So data consistency is a good and interesting challenge here, because you have the source system, it's live, application, users are using applications, changing the state of the data services while you run the migration for the first time. At some point, you need to be able to ensure that now nothing is going to change for a while, because then you run the last data sync step as mentioned before. This may go rather quickly, but it takes some time, and during that time you don't want to have the state of the applications or data services change, and that's why you are very likely to introduce a downtime. Now, it is potentially possible to have an application that lives very well with coexisting in two different Cloud Foundry environments, especially if data service automation is smart and multi-data center capable, which in most cases, that assumption doesn't really work out. So in most of the cases, migrating data from one Cloud Foundry environment to another, you will have a downtime, and maintaining that Cloud Foundry lockdown to a minimum is the basic idea of having that first run where the bulk of the data is already transferred, so that you create a lockdown when then only that remainder of the state changes are being synced. Whether this is data from Cloud Foundry itself or data from your apps stored in data services, doesn't matter. The same rule applies. Lock access to it, perform the migration, and then relieve that lock. There are multiple ways on how you can do that. You could, for example, lock the load balancers. You can create firewall rules, for example, allowing your migration tool access while you basically exclude anything else. So at the migration day, when you've been through all that thoughts and you've created your migration logic, it's time, it's showtime. You run your migration, the first run before the migration day. Most of the data is already synced. You disable Cloud Foundry access to ensure that consistency. You run your final migration. You make sure that that apps can run in both environments. If you have singleton apps that don't work well, if there are multiple instances of them, this is on a case-to-case basis. If you don't have them, then you can skip this step. You start the apps in the target environment and make sure that all apps are running. That's where it's important that also your applications have certain application monitoring. That you reconfigure the Cloud Foundry target to use the final domain you would like to use, and cut over traffic to the target Cloud Foundry would be the next step. Well, obviously, after you've switched that system from the targets, from the source system to the target source system being productive, you also need to ensure that everything is working. So you should have a proper monitoring in place for both your applications, as well as your Cloud Foundry environment, as well as your data service instances, to ensure that such migration works. So, to sum it all up, migrating environments with thousands of applications is nothing scary if you have certain practice, if you've done your homework and you know what you're doing. Most of these steps can be automated. However, we're talking about a framework here. There's a lot of case-by-case code because each migration is different. And solving that problem space of migrations in a generic way would be very, very hard to achieve, because the space of possibilities is just too big. So there's a migration to a very large extent. We've actually built over time scripts that help us with the most common cases. But still, there's always something new to work on. So depending on the application workloads, we're looking at 1 to several hours of downtime for that last sync. In most of the cases, this can be done in a time window where there's little traffic on the system, and the benefits of performing such a migration, let's say from a commercial vendor to a more cost-effective vendor, or from a more costly infrastructure to a cheaper infrastructure, or from an unreliable infrastructure to a more reliable one, outweighs by far the effort you have to invest in such a migration. So it can be done which should give you confidence if you look at a migration project yourself that you can pull it off. So that's the end of the talk. I hope you've learned something new today and you feel now empowered to approach your own migration project because you've learned on what the pitfalls could potentially be and have some ideas on how to circumnavigate them. Well, thank you very much for your time and see you next time. Bye-bye.